All right. Thanks for joining our session. We're going to talk about serverless Java. So in this picture, you can see Boston and Antwerp. So I'm from Antwerp, Belgium. Daniel lives in Boston. So that's why we posted that picture. But anyway, so here's a survey from the CNCF, the Cloud Native Computing Foundation, and they asked organizations what factors are leading you to overspend. And the number one reason that that organizations say is over provisioning. For example, workloads using more resources than necessary. And then another one is sprawl, such as resources not deactivated after use. And then maybe a little bit less, but also like fluctuating consumption demands, where sometimes there's a lot of traffic, sometimes there's not. And then poor planning and prediction on cloud consumption. So those are some really valid reasons why organizations are kind of spending more money than they should, right? So that's one of the reasons why serverless is a really interesting concept, where you're able to scale based on the demand of the moment. So that's what this talk is about, and then with a particular focus on Java, because we're both Java developers. So this is kind of combining those two topics, because originally, Java is not necessarily the best language for serverless, because it's designed for long-running process, whereas serverless is like, well, you want to scale up and down quickly, so things need to start up faster, right? Anyway, so my name is Kevin. I'm a developer advocate at Red Hat, and with me is Daniel.
Hi, my name is Daniel O. I'm from Boston, and so we are all Java champions, and also I'm long-time CNCF ambassador, so which we really love to show how Java fit in serverless and cloud environment. And so one more thing, so we have your social media handler, so you can actually find us, Google searching, and like a Twitter, X, Blue Sky, LinkedIn, whatever you want. Yeah, just feel free to reach out to us if you have any question around this topic and Java and even AI. We are more than happy to address that question. So everybody heard about this serverless, right? And then to serverless, there are some tricky words. So there actually servers, a lot of servers in the behind the scene. But it's not just one framework, not platform. It's like a more how to deploy application into cloud and some platform. So Kevin mentioned earlier, so if you don't have any workloads or network traffic, so your application doesn't need to stand up or running all the time to save your money and save resources in a more like efficient way. So it's we could say like a more deployment model rather than how to develop application. But today we're gonna walk you through how to develop Java application optimized in serverless architecture and serverless platforms. So traditionally, you probably have many experience, even if you are not an operation team, but a lot of people are actually similar experience. When you deploy application in the cloud, doesn't matter Java.NET, Python, or any virtual machine, or cloud, or even bare metal. So application always, you cannot expect how many workload, how many resources you're going to spend, because you have some seasonality or some unexpected spikes. So sometimes like Black Friday or Christmas season or some other stuff, even if you expect, oh, we need to expect maybe more than 10,000 users coming up to our system, but it turns out only like 50% of people actually showed up due to some competitor or some other stuff. So that's why you probably over-provisioning issue or under-provisioning issue. So over-provisioning issue, you just need to spend more money, like some compute resources, like CPU, memory, hard disk, or storage, and so on. But if you have under-provisioning issue, maybe your server is going down and nobody accesses that system. So that is a great reason and like a compelling event why you need to consider about serverless, because serverless is really on demand. So you don't have any over-provisioning, under-provisioning issue. You just deploy application based on when you deploy application and running on, and invoked by like a web front application or a REST API or some other stuff. And it literally start up your application. We can call that cold start strategy or patterns. And then once your application just job done, and like goes down and hibernate, whatever you call that, and your resources is going down too. For example, in the Kubernetes and container, so when you deploy application Kubernetes, your application container pod scale 1 or based on your replica, maybe 10, 20, whatever you want. And after your application job done, okay, there's no incoming traffic and workload in the next like 10 minutes or 5 minutes, depends on your configuration. So that resource is also going down like a 0 pod. No more utilization of that resources like CPU, memory, and among others. So this is an interesting like a diagram here. So left-hand side is the all blue box is a Kubernetes workers. Maybe you could say your many virtual machine or another stuff. So that a small piece of the box is like a Java application within Quarkus, but you can say any your business application. So your application running on time on production environment, and the others empty blue box is all like a idle resources. You already have like 100 Kubernetes workers expecting a lot of application, but in reality, and at some point, you have only limited application and running on time. However, on the right-hand side, you can see that with the serverless, you have more efficient utilization of resources. And then once your application just job done and the application gone, and then you don't have idle resources, and then you have another application deployed, which means actually, oh, I'm going to go to some subscription page, or I'm going to go to shopping cart page and then click on some action, and it literally start up your new application, which consume your existing resources rather than running all the time. So this is more on-demand services, and then you literally save your cost and then makes everybody happy, right? So this is one of the great, interesting some survey from Datadog like a while ago, but this is still true. So more than 50% org actually they just already starting adopt the serverless. Doesn't matter any kind of languages, but as Kevin mentioned earlier, Java is keep evolving really fast. So Java is also super light right now, and a small memory footprint utilization also. So a lot of companies are actually using Java right now to deploy functions as serverless across multi-cloud, not only Amazon and Google Azure, but also there are many serverless platforms.
So maybe a question, how many of you are using any kind of serverless solution right now? We got a few hands, and who of you uses like AWS Amazon Lambda or Azure Functions? So most of the same ones, right? Okay, good to know.
Okay, any of them actually use Kubernetes, like a Knative style container? That's awesome. Okay. Yeah, perfect. Yeah. So let's try to really take one step back, try to understand the journey of a serverless. So we're going to really bit summarize and recap how serverless technology keep evolving, some along with the Java technology as well. So probably you remember that Amazon Lambda is unleashed upon the world like back in 2014, like a November timeframe. At the time, that is the first serverless function on the cloud, and the limited like a functionality and capability. You can only deploy function and with a limited language like a JavaScript or some other stuff, and the limited time you cannot deploy like a long-running process or a high computing stuff on serverless. You can technically do that, but you have to pay a lot of money, which is not good use cases. And after that, some people said, oh, that is a maybe experimental thing to deploy application, just upload my application and running on serverless. And then that's not true. And more and more hybrid cloud company, they launch a new serverless feature and functionality like Amazon Lambda, which is Azure function, Google Cloud Run and function, and IBM function, and among others to keep going on. So for Java developer, how do I develop my like a traditional or new microservices as a serverless or a function? As you can see, here's a code snippet here for Amazon Lambda, which is the most popular thing. And the Amazon Lambda, you can see that there are import. You have lock-in some Amazon Lambda SDK and dependencies and libraries. That's the truth. That kind of stuff. And the enterprise company keep moving forward to more flexible architecture, which is like a multi-cloud and hybrid cloud. So once developer develop application, and you can deploy any platform, any cloud, because your business application is still the same, and serverless functionality is the same, but I just want to deploy this application Amazon Lambda and Azure Cloud and also Google Cloud, because sometimes we're going to expand our some branch like somewhere Europe and somewhere North America, somewhere like Asian country. In some reason, we cannot use Amazon Lambda, like due to some security and governance and or some prices. So in that case, we're going to just extend our other cloud, so serverless function. But business application is still exactly same, like the same thing, like a REST API or some data transaction among others. So why do I need to migrate my application, just deploy new environment? That is not good practice. And
yeah, so here you can see, so you have all the proprietary Amazon libraries, and then you have to implement this request handler, and then you use this Lambda logger and everything, and it works great. But of course, then if your organization is like, well, our CEO went golfing with some salesperson from another company. We're moving everything to Google or to Azure. Well, this is not going to work, right? It's a major rewrite. It's not just changing the infrastructure.
Yeah, absolutely. So, but that's not just only your some consideration when you try to adopt a new serverless function in specific cloud. You can also not individual Java developer, but also your like operation team or a senior level people figure out like some governance, regulatory, or some price policy, or just Kevin mentioned, new CIO actually came from Amazon, and I love to use Amazon, but currently we are using Azure. Okay, we're not going to use Azure anymore. So there are many political reasons, and then like a budget issue. In that case, you probably always design and develop your application more cloud agnostic. So just this example mentioned again. So the lock-in is not good for flexibility and scalability across multi-cloud and then even hybrid cloud. So that is a big challenge or roadblock when developer implement new serverless function with Java. So we're gonna think about how to get we start with the writing new cloud agnostic function. So main goal is here. So I'm gonna develop one like a serverless function, even simple one, and then I'm gonna just deploy multi-serverless platform, Amazon, Google, Azure, or Kubernetes. I don't want to change my application at all, business application, but I probably change some configuration because I need to manifest some target. Okay, this is a target for Azure, this is for target Google. Some kind of configuration, that'll be okay. But I don't need to change any source code for application logic. So we're gonna go with this some Java and serverless, but for that we're gonna use Quarkus. Quarkus actually was born like 4.5 years ago, invented by Red Hat.
5.5 even.
Oh, yes, time so fast. And then we actually donated to non-commercial organization and foundation Common House, so which allows Red Hat and a lot of people using and contribute back to Java framework and Java, the Quarkus stuff. So Quarkus actually designed for more cloud-native microservices, not only like a traditional use cases like a REST API and like a data transaction or even web application. So whatever you go with the Quarkus, for many different use cases, and Quarkus already gives some great developer productivity, but also optimization or resource management. For example, here's some number here. When you run the application with the Quarkus on top of the JVM, it's way lighter and way faster than among other like a Java framework. So like a Spring Boot, Halodon, Microdon, so you can we could really find this all kind of number. You can actually give it a try, develop new Quarkus application.
So the main reason why we're showing Quarkus is, well, aside from us being developers on Quarkus, is because for serverless you need application that start up really fast, because if an application scales, you need it to start up fast to be able to use your platform in the most flexible way, right? So you need something that starts up fast, and you want something that uses limited amount of resources, because with the different cloud providers, you're paying for the memory usage or CPU, kind of depending on which provider you're using. So it's really important in terms of flexibility and for cost savings to use something that that is very efficient in terms of those kinds of numbers. So, there's other stacks that are quite efficient too. Quarkus in particular is just a little bit easier to use as well, and a little even more performant. And so that helps because you can also do a native compilation super easy with Quarkus to really kind of rein in those resources. So that's, kind of the background of that too.
Yeah, absolutely. Yeah, that's a really good catchy point. So Cold Start, I already said that all serverless platform just hibernated, and then when you got an invocation and it actually start up like a warm up, it takes some time. But also technology really fast evolving, so you don't want to wait for like even a couple of seconds. If you go to some website and a mobile, and then I need to take more than like 30 seconds waiting for that. I'm done. I'm gonna just stay away, and then I'm gonna go to another one. So that's why the fast startup time is really matter, and also small memory footprint, because you can deploy maybe 1,000 applications, and it always matter of your money. So with the Quarkus provide more than like 1,000 library and ecosystem right now, and then one of the interesting. Excuse me, for serverless, there are the funky extension. I love this terminology though. So funky make you happy for Java developer. So with one single annotation here, func, you can see that on top of the grid method. That's exactly making your application cloud agnostic. So you can see that hello world, the greeting method, it's a pretty much a classic normal like a API, just hello world, and then one annotation. This application make your microservice as a serverless function across cloud environments. Behind the scene, when you build and package application, Quarkus generate a bunch of the manifest, like some script file and some binary, targeting Azure, targeting Google Cloud, targeting.
Show this in a demo, right?
Yeah, sure, I will do that. So, and also cloud event, not only like a REST API, but also like an event-driven application using cloud event. The tech Kevin, he's gonna really talk about the detail of cloud event a little bit later. So Quarkus also provide like a CLI. You can also using a Maven or Gradle, but also Quarkus CLI pretty much easier with some auto completion to Quarkus create application. Like application name, and for example, I'm going to create a funky annotation which is specifically targeting Amazon Lambda, and then this is one of the stuff here. So let me jump into my demo. So today I have prepared 3 cloud. One is Amazon Lambda, just in case this is a very slow Wi-Fi networking, so I can give it a try to deploy from my local to Amazon. So the cloud in the United States, so maybe it will take some time. Just in case, I just deploy one in advance. So this is Amazon.
A little bit bigger.
What?
Slightly bigger.
Yeah, sure. So this is Amazon Lambda. This is Azure function. And then this is a Google Cloud. So you can see that just one function actually deployed in advance. And then here's my ID tool. Okay, good. And then I have 3 projects. And the first project, like Amazon Lambda stuff, and then go to application stuff. So we have a pretty simple, this is actually one of our example, Kevin and I, we actually writing a book, this is serverless function stuff. And then this is just like the Java beans, like some landing detail. We just imagine some like a spaceship with some like inspired from Star Trek and Star Wars, some of the stuff. And then here's just some simple method. You can see that the phone annotation and then like a REST API, the landing request, approval landing on planet, Earth, Mars, or some of the Kevin Dubois' own planet.
Yeah, my privately owned planet.
Yeah,
of course.
something like that. So basically, so Quarkus provide the Quarkus demo, the live coding capability. You can actually verify your application functions, features, capability on your local machine. And Quarkus provide, I'm not going to do that every single detail, but let me try to run Quarkus dev real quick and then check it out. So running in a second, it's already started. And I'm going to go to another console window. And then here is my like a call command. You can see that. So this is basically, I'm going to pass down like a planet and key and value result. And then here go the local is the 8080. And then REST API landing request.
Does anybody know Planet Risa from Star Trek? Totally geeky.
Okay.
It's like the party planet, right, on Star Trek.
Yeah, Chem is a private planet. I'm going to change it, something like that. And then you can see that approval landing on planet, Kevin is a private planet, something like that. So now I'm going to try to start my local, just I'm as a developer and in a development process. Okay, I just confirm my application worked totally in my local machine, like just the REST API. And now I'm going to try to build my application to packaging stuff. I'm going to skip the testing stuff.
Yeah, so if you're familiar with serverless functions, so if I want to test my function for AWS, typically on my local machine, I have to like set up a bunch of stuff, or I need to invoke it remotely. So it's a little bit annoying to test. So here, Daniel is showing that you can just test your functions running on your local machine, just in this Quarkus dev mode, and you kind of call it as a REST endpoint, and it's able to translate that. But then once we package it, it will actually create the zip file that that AWS expects, and also added with the libraries that Amazon expects as well.
Yeah. So when I just do a packaging application, just Kevin explained, I have a bunch of the manifest file under the target directory, not only in my like a Uber or the legacy jar file, and then you can see there's some kind of zip file here, and then like a magic script file, which Kevin mentioned. There are a bunch of the AWS command line I have to use that previously to run or deploy or even verify or invoke, but I don't need to remember any kind of stuff. The Quarkus automatically generate using that func annotation.
Yeah, and it does that because we added the Amazon Lambda extension to our. So we just added one little dependency to the project, and then when we package it, it generates all this kind of boilerplate for us.
Yeah. So I just need to run the manuscript file with some parameter or argument, like a create, delete, invoke, any kind of stuff. So I just deploy, and then let me try to refresh my function into Amazon. And now I have a new function like a DevOps UK. And then a great thing is Amazon Lambda, you can actually test on the web console right away. So this is my event name, like my function, and then like a hello world, and I'm going to change that like a planet, and then Daniel, new planet. I love to have one day at some point. And then, and then I'm going to just invoke the testing. And it takes literally, my function is already goes down. And then when I invoke the testing, it actually starts up right now, like a core start. And then Quarkus is really fast. Now I can see that here. So approval for landing for dance, the new planet. And you can actually see that the Quarkus logs here. So this is really, really fast. But I still using JVM, like a jar file. If I do that like a native executable, it's a way faster. So some of them actually hand up the using Amazon Lambda currently. And Amazon Lambda, you can find that the SnapStar is really fast. Even you don't need to even use native executable, but still JVM really fast. Underneath the SnapStar actually using Quarkus. So that's how Amazon actually make it really fast, the Amazon Lambda using JVM rather than GraalVM, like a native compilation. So let's go back to really make it really.
So maybe show real quick, if you wanted to do a native compilation, you just do Maven package and you just add -d native, right, to do a native compilation, because like Quarkus supports it out of the box as well.
Yeah, so Quarkus, you can using Maven, go to every single Quarkus project when you generate it, when you create it from scratch or import some of the stuff onto the like a Maven project, and then we already define profile native. So only thing you have to do is just to pass down profile native, which will automatically generate native executable. So I'm going to go to, for example, just build, and it takes like a rest.
So then it figures out, do you have GraalVM installed on your machine? It'll use GraalVM. If not, as long as you have a container environment, it will pull down a Mandrill container, which is an implementation of GraalVM that's open source. And then we'll do the native compilation inside that container. So you don't actually have to install GraalVM on your local machine to do native compilation. So it's kind of handy.
Sure.
To get started.
So I'm going to do this some more like a step-by-step live demo after lunch, and then you probably stop by and then take a look at the more detail. Okay, it's just done, and then you can see that the native compilation under the target directory. You can see that the runnable, like a 41 megabyte with this runnable, is literally just running on. Okay, so I'm going to go to move to Azure project. And then Azure project is pretty much the same thing. I'm going to go to looking really fast. And the function, you can see that exactly same thing. And then like just a function annotation. But when I go to application property, there is something more. When I go to previous project, the Amazon Lambda and resources, you can see that only I can just set up the root path dash API and go to back to Azure, and then you can see that some of the function name or resource, which is the Azure Cloud resource name. This is like a mandatory value, but my application is exactly the same thing. That's exactly I mentioned earlier. You probably need to add some more configuration for your targeting cloud. So I don't want to run the Quarkus again, but I'm just directly deploy application to Azure Cloud using Quarkus like a deploy command line, which allowed me to deploy this application into Azure Cloud. Of course, I already log in the Azure Cloud using AZ command line, AZ login from my local to my remote cloud in advance. And then after that, the Quarkus already, you already log in. And then I'm more than happy to log in to that resources with that name, like a Quarkus resource group, and then the application name, and then deploy directly Azure Cloud. It really takes some time. So when I deploy this Azure Cloud function at home, it takes less than 30 seconds. But when I give it a try, same thing.
On this network.
Like
maybe you can show in the meantime the target folder, right? Because in the AWS example, we saw that there was a function.zip, and we had a couple specific files for Amazon. And in this case, we have this Azure Functions folder. So a completely different structure, but in terms of our source code, it was exactly the same, right? So we only changed the extension. So the one dependency for AWS Lambda, we changed that to Azure Functions, and the rest is kind of just handled when we do the package. It packages it in a different way for Azure.
So as you can see, there are Azure function manifest automatically generate like a JSON and like a actual artifact like a Java file and so on. So currently we actually using Java 21 because the all three function platforms like Amazon, Google, Microsoft, they only support 21 or 17 also, but not 24 yet. So that's why I'm using 21 right now. So in the meantime, I can actually deploy Google Cloud again at the same time. So Google Project, you actually pretty much the same thing. Go to Java same file, already same thing.
Same file.
Exactly same file. We just had to copy and paste. Only different thing is it's exactly the same Amazon Lambda. So only thing is that you need to make sure log in the targeting cloud. I already log in Google Cloud from my local machine using G-Cloud command line, like a G-Cloud auth login, something like that. So I already log in that, and then, but here is I'm gonna go to target on the Google project. You can see there's something different manifest here. You don't see any Azure, Amazon stuff, but you can see some of the other Bootstrap file and then GCP deploy command line stuff. So this is how to deploy. You can actually using this script file, or you can directly use this G-Cloud command line as well. So I'm going to try to use cloud with this different name. This is the G-Cloud stuff. I'm going to just deploy at the same time. I'm going to go back to Azure. Okay, now I'm done Azure, and then go to Azure and refresh. Now I have a new, this one probably, choose, okay, the second one. And then this is the second one, and then you can have like a fully qualified domain name here. And I'm gonna go back to Azure Cloud, and I can have, put on the command line here. Okay, this is the same name, URL name. Just copy and the command line. And then this is probably Risa on Azure. Let's try that. So now you can have the new, it's exactly same functionality, but I just deploy Azure. When I go back to command line again, Google stuff, it's a little bit take some time again. And then it will deploy in soon enough. And then after that, I'm gonna just do Google Cloud to just run the command line again, and then it will return the same result, something like a same curl command, but only different thing is the URL, which is really served by Google Cloud. And then let me try to, just in case, copy and, oh, Google Cloud is just done. And then go to command line. And in the meantime, let's go back to Google Cloud, and then you can now see new function Dubois UK. And you can see that some detail, and then I just call, and then you can find just one invocation just write on. And you can see the Risa command line, and then if I go to change it, Risa on like a GCP, and then you have a new Risa on the GCP planet. And then it takes a little bit of time to put together your metrics and telemetry data from Google, not real time though. Yeah. So that's all I have. I'm going to hand you over to Kevin and talk a little bit about more details.
Yeah, so I think this is, at least in my opinion, a much nicer experience to use functions in a cloud-agnostic way. The only kind of issue is that, okay, now we deployed a function to Amazon or to Azure Functions, and we can use that, but then what about using something in addition to our function, right? So on AWS, for example, you probably need an API gateway to actually access this function, because by default on AWS, you have to do like a specific invocation of a function. So then you kind of go back into this world of proprietary services specific for this cloud provider. And so that kind of locks you in again to the specific provider, right? So this is an example with AWS where you have, maybe you want to use an event bridge or you want to use some messaging, right? Because at the end of the day, our function works, probably in a system that may be using events, right, where you scale up and down based on events that are coming in. So the serverless kind of movement has evolved a little bit beyond functions and gone into this more of this world of containers, where we can deploy our applications without having to create them as specific functions. We can deploy them into containers, and that allows us to be a little bit more flexible with how we're using our resources and our environments. So the cloud providers are happy to provide you with solutions for that as well. So you can see there's Fargate, there's Google Cloud Run, there's container instances from Azure. So there's those kinds of solutions as well. But if we move to containers, of course, there's solutions like Kubernetes that allow you to not be locked into a specific cloud provider, depending on how you use Kubernetes, of course. We showed examples of how you kind of get locked in with AWS. In this case, we're showing an example with Azure. So here with Azure Container Instances, for example, you can also see you have a similar kind of lock-in, right? Because here's your container instances, which is a serverless way to deploy containers. So you just provide a container image to Azure, and they're happy to take all the deployment headaches away. They manage the auto-scaling for you. But you need stuff around that, right? So you need an Azure application gateway, potentially. You want to use some Azure metrics and everything. And those are all very specific to Azure. So then, well, you can use the same container with a different provider, but then you need to change all those different dependencies as well. So you end up kind of locked in again. So Knative is a project in the kind of the open source space. It's a Cloud Native Computing Foundation project that allows you to use serverless in a cloud-agnostic way. So you can use it directly on Kubernetes, which is an open source platform that you can use on any cloud provider or even on your in your private data center, right? So you can actually leverage serverless in a way where you don't have any lock-in. So Knative provides, makes it easy to deploy containers. So you basically say, Knative, deploy my container. It will automatically configure auto-scaling, so it will look at the requests that are coming in and then scale your containers up and down, or your pods up and down for how much you need it. It has this revisioning thing where every time you change the configuration, it creates a new revision, so you can roll back and forward pretty easily. And it is obviously ready for the hybrid cloud because it's Kubernetes, so you can deploy it anywhere, and supports any programming language because it's just a container, right? So as long as you can deploy it in a container, it does not care what kind of programming language you're using, even though you probably should use Java, right? And it supports event-driven architectures as well. So we talked about functions, so you can use functions as well with Knative. So even developers who don't necessarily know how to create containers can leverage the serverless concept with Knative in the same way that they might be used with Amazon Lambda or one of the other ones. So you can use a command line for Knative, for example, here, where you could do Knative func create, and then use a language. So in this case, we can use Quarkus. There's also Spring. There's also Node.js or Go. It'll scaffold some sample code with a function, and then, of course, you might want to change the source code a little bit. And then once you're ready with your development, you just do k-and-func deploy, and as long as you're connected to a Kubernetes instance that has the Knative operator installed, it will deploy it will compile your application, build it into a container, and then deploy that automatically to a Kubernetes instance, and then handle the auto-scaling, because that's kind of the promise of serverless. It's, on the one hand, it's making deployments easier, and it's also, handling the auto-scaling, the infrastructure kind of for you, right? So it does all of that. If you have containers already and you want to leverage serverless, then you just deploy Knative service create, and you provide a container image, and it will deploy that as a serverless container running on Kubernetes. So that's relatively easy to use, and you're not locked into a specific cloud provider. So you can deploy Knative on EKS, on an OpenShift, on kind of a vanilla Kubernetes. So it's just an operator that you install on a Kubernetes instance.
Yeah, when you do the example, when you create the Quarkus example for k and func, it literally used a Quarkus Funk that capability to generate new Quarkus project. And then when deploy the application K and Funk deploy, it literally behind the scene is a containerized application using like a build pack, like automatically containerize that.
Yeah. So it uses other open source projects to build your application. So beyond that, so we talked about functions, we talked about serverless containers, but like I mentioned, where serverless really becomes interesting is in an integrated platform where you're using events, right? So we have some request comes in, whether that's HTTP or maybe a message that's being sent from, or maybe a Kafka topic or something. We want to be able to handle those requests and then scale up based on how many requests are coming in, scale back down, and then maybe send the message on to another system. So this whole kind of flow is, you probably know it as event-driven architectures. This is where serverless really shines, right? Because you can reuse your systems in a very flexible way. So this is something that Knative also supports out of the box. So it has a couple different components. So you have Knative Serving, which handles the deployment and the management and the auto scaling. And then you have Knative Eventing, which allows you to plug in event sources and syncs. So inputs and outputs for these serverless containers. And then you have brokers and triggers, which, if you're familiar with messaging systems, it's pretty much the same kind of concept. And so I think we have, just making sure. So we have Knative Eventing, which also uses an open source specification, which is called Cloud Events. So Cloud Events is another Cloud Native Computing Foundation project that tries to make the events protocols and structures agnostic as well, because many different messaging providers, they have their own protocol, they have their own way of structuring data. So Cloud Events is kind of a layer on top that makes that kind of abstracted for the user. So you, as a developer, you create your application, you do it ideally in an agnostic way. So either you create containers or you use Quarkus Funky, and then you receive or you send events in this cloud events format, and then the system that's underneath will actually translate and use that into a specific protocol, such as HTTP, AMQP, or MQTT. So you as developer don't need to worry about that. So if one day you're using Kafka as your messaging system, and another day maybe you want to move to something, whatever the next thing for Kafka is, maybe you're using Pulsar or something. For the developer, it doesn't change anything because that layer is abstracted away. So that's kind of the promise of Cloud Events. So Knative supports this Cloud Events out of the box. Google Cloud functions as well. They support Cloud Events as well. And they actually use Knative underneath their system as well. So here you can kind of see some patterns of how you could use that, right? So you have an event source, and then you have your service, your application, and you send this event to our service. Now with Knative, you can handle these events in a more kind of manageable way. So you can have events that get sent to a Knative channel. So this is a custom resource running on Kubernetes that handles the messages and then dispatches them based on who's subscribed to that particular channel. And that channel could be potentially backed by Kafka, right? So as an example, but it's Cloud Events that actually is the protocol that you're using for the developer. So you can also use Knative brokers, so kind of a similar concept, except here you can filter certain messages to send to one specific consumer through a trigger, and then another one who is interested in other types of messages. So you can use event-driven programming in a very flexible way, in a very cloud-agnostic way, where you're not tied into a specific provider. And then you can always back that up with proprietary tools if you would like, of course. we want to see that in a demo, right?
Yeah,
So,
sure.
so we'll kind of show this example first. So the UI is, of course, not so great because we're back-end developers. But what we tried to do here is create this little voting system. So I'll share a QR code so you can vote for your favorite IDE. So we made kind of an opinionated guess here. So you have IntelliJ, VS Code, Eclipse, Vim, OpenShift Dev Spaces, and other. So if you're an Emacs fan or something, you can vote for other. And so we'll share the QR code. And what we want to show you is how you can create a system. This is very over-engineered for this particular use case, but we have a UI here that's running in one serverless container. We have an ingester that's consuming your votes and then sending them onto a Kafka topic, which then is consumed by this processor, which is going to update the database based on how many times you vote, and then our UI is going to display how many votes you've given. So. Should we share the QR code for people to vote? And this is going to scale up based on how many times you're voting. So right now, the system is kind of waiting and sleeping. So once you go to this URL, of course, it's going to wake up. It's going to start scaling some containers. And then we'll see. Sorry, maybe people need to scan.
Everybody's good to scan.
A little bit more.
Yeah.
And then you can start voting. And then we'll show in a second how that scales up the pods. And then once maybe you stop voting, it'll scale back down. It'll just wait for you to vote again. So maybe we can go to the actual demo here, and we can see, as expected at Java conferences, we have a heavy preference for IntelliJ. If anybody feels like they want to make this more interesting and have a quick way to automate your voting, or you can tap a lot of times. Our system is going to scale up and down based on how heavily it's being used, right? So you can see here the pods that are running. So those are served by Knative, in this case on an OpenShift cluster. And you can see there's some pods that are terminating because that's the UI. So once you've gone to the QR code, you open the UI, it's going to scale it up for how many users are using it. But then unless you refresh your browser window, it doesn't need to use that endpoint anymore. So you can see that it's kind of going to sleep. And then we also have the ingester part, which is right now using only one pod. But if somebody starts sending a lot of requests, this is going to scale up to however many requests is needed. So if anybody wants to, if you all want to start tapping a lot and make a lot of votes, then we might see that it's going to scale up faster or not. Let's see. Tap more. Let's see if we can make it scale up. I have a little script, but it's on my other laptop. So otherwise, I would have sent a little burst of traffic with a couple thousand votes. But you'll just have to believe me that it scales up and down. You can see that the UI, on the other hand, is now auto-scaled to 0 because nobody's hitting the UI endpoint. And so it's saying, well, I don't need to be used right now, so I'm just going to go to sleep and wait for somebody to hit it again, which now apparently somebody did. And we're scaling back up to 3 pods. So that's kind of how that works. And so we deployed just a couple containers and then integrated the system using Knative in this case. So it's a very efficient way to use resources on, in this case, Kubernetes in an OpenShift implementation. So who was the winner? Was it still IntelliJ? Because I saw the votes kind of. Wow, we got a Vim fan here. That's very motivated. So that's a silly kind of example, and we'll share the source code for this as well, so you can check it out. This is also using Quarkus, natively compiled. And then it's using Camel Quarkus. So you may have heard of Camel's integration libraries to make integration routes between different components. So that's also in the source code as well. And then finally, so Knative has a serving capability, has an eventing capability. It also supports serverless logic. So you can create a flow of different components that need to be called in a specific way. So if this component is called in this particular logic, then the next component is being called. So that's something that's supported by Knative as well. Maybe something to check out if you have time.
Yeah.
And then, of course, we're in the AI era. So, of course, we need to talk a little bit about AI. And this is actually a really interesting use case for serverless as well, especially serving inference models, but also in terms of MCP. You might have heard of Model Context Protocol, where we have tools that can be called by an AI system, and those can be written, for example, with Quarkus and Java, and you can serve those as serverless. So then, when your LLM is calling a tool, it'll wake up, it'll serve the MCP server, and then go back to sleep. And so you can use the same kind of concepts even for your AI-powered applications. And so, yeah, that's it for our session. So there's some free books that you can always download thanks to the Red Hat Developer Program. And then in the next slide we have the QR code for the slides, so you can you can look at everything. We have some links throughout the slides where you can see the source code. And then you also have our contact information here if you have any other questions. And then if you feel like you want to post about this session, where, of course, please tag us, and then let us know what you think of the session.
Yeah.
Sorry? So if you get the slides here, you'll actually get the QR code, so either way.
Yeah.
And then tonight there's the DevRocks party, and our lovely assistants over there, they have tickets for the party, which is sponsored by Red Hat. So they're happy to give you a ticket if you want to go and have a drink and a couple snacks tonight. And thank you for joining this session. Hopefully it was interesting.